This is Chapter 5, Force and Acceleration, Mass and Acceleration, Newton's second law, and friction. So in Chapter 5 we are talking about acceleration, what causes the motion of objects to change. And a good way to say that would be, say, unbalanced forces, or net unbalanced forces. So that's question number 1. Explain the relationship between force and acceleration using the term directly proportional to. The acceleration is directly proportional to the net force. If the force is increased by double, what happens to acceleration? It also increases by double. Finish the statement, the bigger the force. So the bigger the force, the bigger the acceleration. That's directly proportional. Mass resists acceleration. Explain the relationship between mass and acceleration using the term inversely proportional to. So the acceleration is inversely proportional to mass. And so you can write it a little bit like that. If the mass increases by double, what happens to acceleration? It will get twice less. So finish the statement, the bigger the mass. So the bigger the mass, the smaller the acceleration, inversely proportional to. So write Newton's law stated in the book. You can find Newton's law as a statement. It's a paragraph form on page 60. You can go ahead and write that. Write the text message form of Newton's second law. We wouldn't write the whole thing out in a text, would we? We would just write out the acceleration is equal to the net force divided by the mass, or acceleration is proportional to the net force and inversely proportional to the mass. So that is Newton's second law. It's actually an equation. So then, what would happen if you double the force on a cart, but at the same time double the mass? Well, the acceleration would remain the same because you're doubling both. Okay, on the top of page 62, finish the sentence. 1 Newton is the force needed to. And on page 62, it's a really basic way to say it. 1 Newton is the force needed to give a mass of 1 kilogram and acceleration of 1 meter per second squared. So that is 1, 1, and 1. So moving on to the equations, simple equations with no opposing forces at this point. How much force must a 20,000 kilogram jet develop in order to achieve 2 meters per second acceleration? So the force will be equal to your mass, which is 20,000 kilograms, times your acceleration, which is 2. And then if the force of the jet is 80,000 newtons, what will the acceleration be? So we'll rearrange it any one of these 3 ways, same equation. Your acceleration will be equal to 80,000 newtons, and I'm losing my pen here, 80,000 newtons divided by, this is the jet above, so it's 20,000 kilograms. And then last, my mass actually, if 140 newtons is going to accelerate me at 2 meters per second squared, then it is true. My mass is about 70 newtons. So lastly, we have a situation of friction. So in the first case, if we step on the gas of a car, it's going to accelerate. So we have very little friction. This is the force of friction here. We have very little friction here at the beginning, and we'll accelerate a lot. But later on, as we go faster and faster, the force of friction and the force of wind resistance begins to oppose it, so that the two forces are equal, but in opposite direction, which means the net force is 0, and we have no acceleration. Draw a free body diagram. We basically just drew it. We have friction going this way, and we have the force of the motor going this way, and these forces are equal. And so, same way, we get no acceleration.